Welcome to the deep dive. We love tackling these big questions about the world, and today it's one we all experience. Why does it actually rain?
Right. It seems so simple, doesn't it? Water falls
Yeah.
from the sky.
Yeah. But when you dig into it, it's this whole amazing process, like a giant puzzle.
Exactly. And the key to that puzzle, really, is the water cycle. It's this incredible, nonstop adventure for every drop of water on Earth.
An adventure. I like that.
Definitely. Think of it in three main stages. Water goes up, it turns into a cloud, and then, well, it comes back down again. Simple, but profound.
Okay, so a water drop adventure. Let's follow it. Our mission today, track that journey step by step and figure out what's really happening up there. Try and picture it as we go.
Let's do it.
So where does this story start? Right here on the ground, I guess.
Pretty much. Think about all the water we see, oceans, lakes, rivers,
Even puddles after it rains.
especially puddles,
Yeah.
any surface water. And the thing that kicks the whole adventure off is our sun, the giant star up there.
Okay, the sun. What does it do? Just warm things up.
It does more than just warm it. It gives the water molecules this big energy boost.
Yeah.
Imagine the sunlight hitting the surface.
Right.
That energy makes the water molecules move faster and faster until some of them break free from the surface. They turn from liquid water into an invisible gas, water vapor.
Ah, so that's where the water goes when a puddle dries up. It doesn't
Yeah.
just disappear.
Exactly. It becomes
Yeah.
this invisible gas, water vapor, and it rises up into the air. It's like the sun's a giant hairdryer, you could say, lifting the water off the ground.
Huh. This giant hairdryer, I can picture that. And this whole going up part is called evaporation?
That's the one. Evaporation, liquid turning into gas and rising.
Okay.
And what's really wild is the scale of this. We can't see the vapor,
You
right?
know, it's invisible.
But billions of tons of water are evaporating across the globe every single day. It's a massive, massive transfer of water into the atmosphere. Hard to even imagine.
Billions.
Wow.
Okay, so this invisible water vapor, it's risen up, up. What happens next? It can't just keep going forever, right?
Right? It goes high, high above us. And what happens when you go higher up?
It gets colder.
Exactly. Much colder.
Yeah.
So this warm water vapor, full of energy from the sun, suddenly finds itself in this really chilly environment.
Brr.
Kind of. The cold makes the water vapor molecules slow down. They lose that energy boost, and when they slow down, they start to get closer to each other again.
Okay, they're slowing down, getting closer.
But they need a little something extra. They can't just easily turn back into liquid on their own up there.
Mm.
They need tiny, tiny little specks floating in the air.
Specks. Like what? Dust.
Yeah, exactly. Dust, pollen, little bits of salt from the ocean, even tiny particles from pollution. Scientists call them condensation nuclei.
Condensation nuclei. Okay.
So these cold, slow-moving water vapor molecules bump into these tiny specks, and they stick to them. They huddle together on these little particles.
Like tiny little gatherings.
Perfect way to put it. And this whole process, the gas turning back into tiny liquid droplets by sticking to these specks, that's called condensation.
Condensation. Got it. Like
Right.
when my cold drink gets wet on the outside on a humid day.
Precisely the same principle.
Yeah.
Just happening way up high in the atmosphere on these tiny particles.
So these little droplets form, but that's not a cloud yet, is it?
Not quite. You need millions, no, billions and billions of these tiny droplets all gathering together in one area.
Okay.
When enough of them cluster together, suspended up there, that's what we see as a cloud.
So a cloud isn't just like cotton candy floating around.
Not at all. It's a massive collection of these incredibly tiny water droplets, or sometimes ice crystals, all clinging to those little dust or salt particles.
Wow. So visible clouds are made of invisible gas turning back into water around tiny bits of dust. That's amazing.
It really is. And what's fascinating, like you said, is how something so huge, invisible, like a giant storm cloud, is actually made up of countless microscopic parts. Those little nuclei, the dust and salt, absolutely essential. Without them, cloud formation would be much, much harder.
Right. They need something to grab onto.
Exactly. A little anchor point for condensation to begin. It really shows how tiny things in the atmosphere affect the big weather patterns we see.
Okay, so we have our cloud full of tiny water droplets. What happens inside that cloud? Does it just float around?
Well, it's loose. Yeah, carried by the wind. But inside, things are still busy. The cloud keeps collecting more water vapor, and the little droplets inside, they're bumping into each other
Bumping around.
constantly. And when they bump, they often merge together, becoming bigger droplets. It's a process called coalescence.
Coalescence, like coming together.
Exactly. Tiny droplets join to make slightly bigger ones, which then join with others. They grow.
So the droplets inside the cloud are getting bigger and bigger.
And heavier. Think of the cloud like a giant sponge soaking up water.
Okay, I can picture a sponge.
It can hold a lot, but eventually it gets too full, too heavy. And then gravity takes over, that constant pull downwards. When the droplets get big and heavy enough that the air currents inside the cloud can't hold them up anymore,
They fall?
they fall. Gravity says time to come down. And those water droplets falling back to Earth, that's what we call rain. That's precipitation.
Precipitation. So that's rain. But sometimes it's not rain, right? Like snow.
Good point. If the air is cold enough specifically, below freezing, 0 degrees Celsius or 72 Fahrenheit, as those droplets fall or even while they're forming,
Yeah.
they can freeze into ice crystals. And when lots of these ice crystals clump together, they fall as snowflakes.
Ah, so snow is just frozen rain, basically.
In essence, yes. Or sometimes, if there are really strong updrafts in the cloud, raindrops can get tossed up and down, freezing and collecting more water, forming layers of ice.
And that makes...
Hail, those balls of ice.
So precipitation isn't just rain. It can be snow, sleet, hail. It all depends on the temperature up there and within the cloud.
Got it. Temperature's key. Absolutely.
Yeah.
The whole journey down determines what form it takes when it reaches us. It's all about that interplay between the droplet growth, the temperature, and, of course, gravity pulling it all back down. Without gravity, the clouds would just keep growing, maybe drift around forever.
And we'd never get the water back.
Precisely. No replenishment for rivers, lakes, plants. Us.
Okay, so the waterfall, rain, snow, whatever it lands back on Earth, in the oceans, lakes, rivers, on the ground. And then, does it just start all over again? The sun shines, the water evaporates?
You got it. That's the cycle.
Mhm.
It lands, and the sun's energy gets to work again, warming it up, turning it back into vapor, lifting it up.
Mhm.
The whole amazing journey begins anew.
Wow. It really is a never-ending cycle.
Completely. It's been happening for billions of years.
So the water in my glass right now, it could have been rain last week.
Easily. Or snow last winter. Or part of an ocean current thousands of miles away years ago. It's all the same water, just constantly moving, constantly changing form, going on this grand tour of the planet.
That's kind of mind-blowing when you think about it.
Isn't it? And if you connect that to the bigger picture, this constant cycling, it's literally Earth's life support system.
How so?
Well, think about it. It naturally purifies the water through evaporation, leaving salts and impurities behind. It transports fresh water across vast distances.
Yeah, clouds move it from oceans over land.
Exactly. It delivers water to forests, farms, fills our rivers and underground aquifers. It shapes landscapes through erosion, influences climate. Everything depends on this constant movement. It's what makes life on land possible.
So it's not just about why it rains, but how incredibly important that whole process is.
Fundamentally important. It's the planet's plumbing and air conditioning all rolled into one elegant cycle.
Okay, so let's recap this amazing adventure. Water on the ground gets heated by the sun,
Evaporates. Turns into invisible water vapor. Rises up.
goes way up high where it's cold, bumps into tiny dust specks.
Condenses. Turns back into tiny liquid droplets forming clouds.
Inside the clouds, the droplets bump together, get bigger and heavier.
Coalesce. Until gravity pulls them down.
As precipitation, rain, or if it's cold enough, snow or hail.
And then it lands. Ready for the sun to start the journey all over again.
Wow. That really changes how you think about a rainy day, doesn't it?
It really should. It's not gloomy weather. It's this vital part of an incredible planetary engine doing its work.
So next time it's raining, we'll know it's just the water on its grand essential adventure.
Absolutely. And maybe, just maybe, take a second when you feel that next raindrop. Think about the journey it's already taken. From an ocean, maybe, up into the vast atmosphere, part of a cloud.
Yeah.
And think about the journey still ahead for that very same drop. It connects you, connects everything to this huge vital system that keeps our planet alive and thriving. It's a constant silent dance that sustains us all.